Alright, 2-3. We're going to talk about segments and distance. First thing is just a quick review of a line segment. Remember, a line segment is a part of a line consisting of two endpoints and all the points in between them. So this is a picture example of a line segment. Part of a line. Two endpoints and all the points in between them. A coordinate is a number that provides the location of a point. So if you are on a number line and you have point A, the number that goes with it is the coordinate. So this is the name of the point. This is the coordinate of the point. It gives the location. Alright, to measure the length of a segment, you can use a number line to find the distance, so by counting between the two endpoints, or you can use the following formula. Okay, what this says is the absolute value of A minus B. Remember, absolute value means that basically everything's positive. So if when I subtract A minus B I get a positive number, absolute value doesn't change anything. Everything stays the same. But if when I do A minus B I get a negative number, absolute value will change that to a positive. And the reason for that is, if we're finding the distance between 2 points, or the length of a line segment, you can't get a negative number. If you look at a ruler, you'll notice there are no negative numbers on a ruler. You can't measure the length of something and go, oh yeah, that's a negative 5 inches. That's not possible. The length of a segment, or the distance between 2 points, is always a positive number. So that's why we have the absolute value here. Okay? Now the A and B in the formula are the coordinates of the endpoints of the segment. Okay? So find the distance between -2 and 6 on a number line. Well, these are the coordinates of the two endpoints, so I can just take these two numbers and plug them into the formula. Now which one is A and which one is B does not matter. That's what the absolute value keeps that from being an issue. So if I take -2 and make that A, and I subtract B, and B would be 6, and I take the absolute value of that, I'll find the distance between those 2 points. So a -2 minus 6 is a -8. And again, because we're doing absolute value, that -8 becomes a +8. Now, let's say I had used those two numbers in a different order. Let's say I made A 6, and then we got 6 minus B. Now, B is a negative number. We are subtracting, and then the number we are subtracting is a -2. When you subtract a negative number, you are actually adding. When you subtract a negative like this, you don't have to take the time to rewrite it, but subtracting a negative is the same as adding. And 6 plus 2 is 8. And anytime it's a positive number, the absolute value is not going to change anything. So once again, you get 8. So you do not have to do both of these. You only do one or the other. But either way will work. Alright, example 2. Find the distance from P to Q, the distance from Q to R, and the distance from P to R on the number line shown below. We talked about understanding the language of geometry, knowing how to write something and mean what you're trying to say, and how to read something and know what they're telling you. It's very important when we name lines and segments and rays and things that we always put the correct symbol over the top. Because if you don't, it means something completely different. When you have two letters like this, 2 points together like this, and you do not put any symbol over the top, we read that as the distance between these 2 points. Okay, so when I read PQ, we read that as the distance from P to Q. That's how that is read right there. So it's important that you are reading that correctly and understanding what it's looking for. Okay, so to find the distance between the 2 points, we're going to get the coordinates of the 2 points and plug them into the formula. So P is at the point -3.5. It's halfway between -3 and -4. So P's coordinate is -3.5. And Q's coordinate is -2. So I'm going to take those and plug those into the formula. Again, it does not matter which one's A and which one's B. So I'm going to make P A, and then from that we subtract B. Notice we are subtracting a negative number. When you subtract a negative number, you are actually adding that number. Okay, so negative 3.5 plus 2 is a negative 1.5. But again, we are doing absolute value, and so that's going to end up being a positive 1.5. So the distance from P to Q is 1.5. Now you could count that on the number line. The one thing you need to be careful about is make sure you're counting by the correct units. There is a dash for every half here. Okay, so make sure you're not counting 1, 2, 3 and thinking the distance is 3. That's 3 halves. Okay, so it takes 2 halves to make a whole, and then we got 1 other half. So you got 1.5. Okay, let's get the distance from Q to R. So first, let's get the coordinates of each endpoint. So Q is at the point negative 2, and R is at the point 2.5, or 2.5. Plug the numbers into the formula. So we got A minus B. It doesn't matter which one's which, because we're going to do absolute value. So negative 2 minus 2.5 is a negative 4.5. And again, because we're doing absolute value, it's going to come out positive. So the distance from Q to R is 4.5. If we were to try to do that, it's 1, 2, 3, 4.5. If we're counting on the number line. Now, even if you are good at counting on the number line, it's still important that you learn how to do this formula. So even if you can count it and figure up your answers, I want you to go through this process. Right now the numbers are close enough together that yes, you could count and you can get it. But what if one of your endpoints is at negative 72 and the other endpoint is at 168? You're probably not going to want to count that. Okay, so this is a much quicker, easier way in that circumstance. Now, once you learn how to do this properly, if you have a problem that's easy to count, feel free to count. But I want you to practice this way first to make sure that we are getting it and understanding the process. Okay, so now we want to find the distance from P to R. P, again, is at the point negative 3.5. That's its coordinate. R, again, is at the point 2.5. So we're getting the distance from P to R here. Okay, so absolute value of A minus B. So A minus B. Make sure we're doing the absolute value of that. Okay, so negative 3.5 minus 2.5 is a negative 6. But then absolute value will make that positive. And the distance from P to R is 6. Alright, when a segment is drawn on a coordinate plane, you can find its length by using the distance formula. So just a minute ago, we found the distance between 2 points on a number line. That's a one-dimensional line. Now we're talking about being on a coordinate plane. A coordinate plane is when you have your x-axis and your y-axis, and you got your points anywhere on here. Now we got 2 dimensions. Okay, so we have a different formula for this. So here's the distance formula when you're dealing in 2 dimensions on a coordinate plane. Okay, we got x sub 2 minus x sub 1, and that is squared, plus y sub 2 minus y sub 1 squared, and then we take the square root of that whole thing. Now don't get thrown off too much by the x1, y1, x2, y2 stuff. If you have 2 points on your coordinate plane, and you're trying to find the distance between those 2 points, each point has an x value and a y value. That's how we plot the points. That's how we find the location. So this point also has an x value and a y value. Now, because we're dealing with 2 different x's and 2 different y's, we got to distinguish between the 2. So one of the x's will be x sub 1, and one of the x's will be x sub 2. Same thing with the y's. Now, the key is, whichever, you can make either one of these x's x sub 1. Does not matter which one. But whichever one you decide to put the 1 on, the y needs to also have the 1. The x sub 1 and y sub 1 should come from the same point, and the x sub 2 and y sub 2 should come from the same point. Okay, so let's look at example 3. We want to find the distance between these 2 points. So, X is always the first number in ordered pair, Y is always the second number. X is always the first number, Y is always the second number. It does not matter which one of these is point number 1 and which one is point number 2. It does not matter at all. But the X and Y from the same point should have the same number. Okay, so if we want to find the distance between these 2 points, we're just plugging them into the formula. That's all there is to it. So we want X sub 2, which we identified to be negative 2. And then we're subtracting X sub 1, which is 2. And then that is squared. Then we have Y sub 2, which is negative 1, minus Y sub 1, which is a negative 1. Now right here, you are subtracting a negative, which means you will add. Now be very careful. The most common mistake I see on distance formula is people just writing negative 1 minus 1. There is a minus sign or a subtraction sign in the formula. Write that down before you go find out what this number is. Then when you see that this number is negative, that negative's got to be there too. And now anytime you have both signs at the same time, that's subtracting a negative, that's when you know you're going to add. Okay? Now, you got 2 options here. If you have a calculator, if you have a graphing calculator or a good calculator that you can type a whole bunch of stuff into all at once, you can just type this whole thing in the calculator and it understands order of operations and it will solve it for you. If you do not have a calculator, then we need to follow our order of operations. So remember PEMDAS. First thing we do is whatever's in parentheses. So what's inside the parentheses here? Negative 2 minus 2 is a negative 4. Negative 1 plus 1 is 0. Okay, PEMDAS, parentheses, then exponents. We got a couple of exponents here. So we're going to square these. Negative 4 squared is a positive 16. This is something a lot of kids will mess up on. If you just type in your calculator negative 4 squared, it's going to say it's a negative 16 because it will only square the 4. If you want to put it in the calculator and get the correct answer, you're going to have to put parentheses around the negative 4 before you square it. Remember, squaring something means you multiply it times itself. So if I say negative 4 times negative 4, remember a negative times a negative is positive. Alright, and then 0 squared is 0. Okay, then we're going to go ahead and add these together. 16 plus 0 is just 16. And the very last step is to take the square root. And the square root of 16 is 4. So the distance between these 2 points is 4 units. Alright, let's do it one more time here with this formula. Remember, this is x1, y1, x2, y2, and we're plugging them into the formula. So x2 minus x1. x1's a negative, and we're subtracting a negative. I'm going to go ahead and change that to plus. Then we got y2 minus y1. So y2 minus y1. We got everything plugged in. Again, you can type the whole thing in your calculator right now if you want to. I'm going to go ahead and use order of operations to do it on the paper. So what's inside the parentheses? We got negative 2 plus 5 is 3. And we have 3 minus 2 is 1. After parentheses is exponents. 3 squared is 9. 1 squared is 1. Add them together. Take the square root. Now if you take the square root of 10, you're not going to get a whole number. But notice in the directions that it said round to the nearest hundredth. So we do square root of 10. In the calculator, it says 3.1622, whatever. It goes on and on. If we are rounding to the nearest hundredth, we want to keep 2 numbers after the decimal point. Think about how many zeros are in the number 100. 2 zeros in the number 100. We want to keep 2 places after the decimal point. So you always look at the first number you're not keeping to decide whether to round up or not. So the first number we're not keeping is the 2. Remember, we only round up if that number is 5 or greater. Okay, if it's smaller than 5, we're not going to round up. So this is 2. That's not smaller than 5, so we do not round up. So all of this just disappears, and your answer is 3.16. Alright, let's look at example 5. It says find the distance from A to B. Alright, now the difference between this problem and the other problems is instead of giving us the coordinates of the points, they gave us a graph, and you have to figure out the coordinates first. So you just got one extra step here. So the first thing we need to do is write down the coordinates for A and write down the coordinates for B. So on your coordinate plane, your left and right is your x value, and that is the number that comes first. The up and down is the y value, and that is the second number. Okay, remember for x, if you go to the right, it's positive. If you go to the left, it's negative. So you can see that both of these are to the right of the origin, so they're both going to have positive x values. Okay, for y, when you go up, it's positive, and when you go down, it's negative. So you'll see that b is going to have a positive y value, while a is going to have a negative y value. So if I'm counting from the origin to a, the x value is 2, and then the y value is negative 3 because we went down 3. So the x value, we went 2 to the right, and we went down 3. It was a negative 3. For b, from the origin to get to b, we go right 1, 2, 3, 4. So the x value is 4. And then we go up 1, 2, 3, 4, 5. So the y value is 5. So there are the coordinates of the 2 points. And from here, we just do the exact same thing we did on the last 2 problems. So we label x1, y1, x2, y2, and we want to plug those into the formula. So first parenthesis is x2 minus x1. So we got x2 is 4 minus x1, which is 2. Then we have y2 minus y1. y2 minus y1. We're subtracting a negative, so I'm going to change that to plus. Okay, you can put it in the calculator now if you want. I'm going to do order of operations on the paper. 4 minus 2 is 2. 5 plus 3 is 8. After parentheses is exponents. 2 squared is 4. 8 squared is 64. Add them together. Take the square root. Now when you take the square root of 68, not going to get a whole number. We're going to have to round. Once again, it says round to the nearest hundredth. So we want 2 places after the decimal point. Now when I put this in the calculator, I get 8.2462, whatever. I'm only keeping 2 numbers after the decimal point. So I look at the first number I'm not keeping, and it's a 6. Now that number is 5 or greater. It's big enough to round up. So that means the last number that I am keeping needs to increase by 1. So instead of being 8.24, it's going to be 8.25. And that is the approximate distance between point A and point B on this grid. All right. It says examine the measures of the distance from P to Q, the distance from Q to R, and the distance from P to R in example 2. Notice that 1.5 plus 4.5 equals 6. So, now where they got those numbers from, if you're looking at example 2, the distance from P to Q was 1.5, the distance from Q to R was 4.5, and then the distance from P to R was 6. So here's P to Q, here's Q to R, oops, and then we got from P all the way over to R. And so 1.5 plus 4.5 equals 6. These 2 segments add up to equal the larger segment. So what that means is, if we're writing this as a statement here, the distance from P to Q plus the distance from Q to R equals the distance from P to R. And it suggests the following postulate. This is called the segment addition postulate, and we will use this a lot this year. It says if point Q is between points P and R, then the distance from P to Q plus the distance from Q to R equals the distance from P to R. So you might recognize this right here. If the distance from P to Q plus the distance from Q to R is equal to the distance from P to R, then Q is in between P and R. So it works both ways. If you know this point is between these 2 points, then this has to be true. If you already know this is true, then Q has to be between the 2 points. It works both directions. So here Q is between P and R. So I know that the distance from P to Q plus the distance from Q to R equals the distance from P to R. All right, so let's try this. Try applying this postulate to the examples we got next. If B is between A and C, now before I go any farther, I'm going to draw a picture. It helps to have a visual. B is between A and C. B is between A and C. The distance from A to B is 4. The distance from A to B is 4. The distance from B to C is 5. Then what is the distance from A to C? According to the segment addition postulate, we're just doing 4 plus 5 equals 9. So the distance from A to C is 9 units. Just think about taking a trip and breaking it up. And B is somewhere between your start point and your ending point. You don't know where it is. It's not necessarily in the middle, but it's somewhere in between them. So you travel 4 miles to get to B, you travel 5 miles to get to C. What was the length of the entire trip? 9 miles. Okay? Let's look at the next one. If the distance from A to B is x, and the distance from B to C is x plus 6, and the distance from A to C is 24, then find the distance from A to B and the distance from B to C. It didn't say in the directions, but we're going off of the same premise up here that B is between A and C. So if B is between A and C, I'm going to draw a picture. The distance from A to B is x. The distance from B to C is x plus 6. And the distance from A to C is 24. Now before we can find the distance from A to B, or the distance from B to C, we need to know what x is. And the only way we're going to find out what x is if we set up an equation so we can solve for x. Well, the segment addition postulate said that these two parts add up to equal the whole. So I'm going to set up the equation just like that. X plus 6, those two parts should add up to equal the whole thing, 24. So there's our equation. Now we just solve for x. So left side of the equation is not simplified. I got like terms I can combine. We got 1x plus another x. That's 2 x's. X is already only on one side. I just need to get x by itself. So first step, get rid of the constant. It's being added to x. We're going to do the opposite operation to get rid of it. So we're subtracting 6. Then I want to get rid of the 2. X is being multiplied by 2. The opposite of multiplying is dividing. So we'll divide by 2. And 18 divided by 2 is 9. Now that's what x is, but that's not our answer. It will be one of our answers, but we want to find the distance from A to B. The distance from A to B is x. Well, x is 9. That means the distance from A to B is 9. The distance from B to C is x plus 6. So if x is 9, we got 9 plus 6 is 15. So the distance from B to C is 15. And you can check yourself and make sure those add up to 24 to make sure you didn't make any mistakes. 9 plus 15 does add up to equal 24. All right, last one. Find the distance from L to M if L is between N and M. So before I go any farther, I want to set up a picture where L is between N and M. It says the distance from N to L is 6x minus 5. The distance from L to M is 2x plus 3. And the distance from N to M, the whole thing, is 30. So once again, I'm going to use the segment addition postulate to set up an equation so we can solve for x. And then once we have x, we can plug it back in here to find out what the distance from L to M is. So again, segment addition postulate, these two parts are going to add up to equal the whole thing. So I'm adding these together. This part plus this part equals the whole thing. And now it's just solving an equation. You've done all the geometry, now it's left to algebra. Okay, left side of the equation needs to be simplified. We got like terms to combine. We got 6x and 2x. So that's 8 x's. 6 plus 2 is 8. And you got constants. You got negative 5 and 3. So negative 5 plus 3 is a negative 2. So both sides are simplified. The x is already only on one side, so we just need to get x by itself. Got to get rid of the constant first. It's being subtracted from x, so we'll do the opposite and we'll add it. Doing the opposite operation with the same number is what gets rid of it. And then x is being multiplied by 8, so to get rid of that 8, I'm going to divide by 8, the opposite of multiplication. And 32 divided by 8 is 4. Now, that's not our final answer. Our goal was to find the distance from L to M. Well, the distance from L to M is 2 times x plus 3. So now that I know x is 4, I can substitute 4 in place of x. 2 times 4 is 8. 8 plus 3 is 11. And there's the answer. The distance from L to M is 11.